Hello, everyone. Welcome to the BCH2024 module. My name, by the way, is Marcelo Ponce. I'm going to be your instructor for the course. So I think we had a good number of you guys. So usually we like to have this type of courses in person, but as you know, in the current situation, we will have to do it online. So today's lecture is going to be our first lecture, of course. Just to let you know, the lectures are going to be recorded. They are also being streamed live on YouTube. This is mostly as a backup recording, but also if you guys want to watch it later, either on the course website or on YouTube, that would be fine. Today's lecture, I will spend a little bit of time talking about the course and some of the details about the course and how it should work. And so one thing that usually happens with these courses, they are very, very practical in the sense that in many cases you can do hands-ons, and you know, it's complicated to do it online. Usually when we do it in person, it's easier, or at least it's more agile. But hopefully we can try to make it work. This is the second time I'm teaching this course, and I think the first time it works just fine. But we can talk about these details and other things, other idiosyncrasies about the course as we move forward. I'm going to keep an eye on the chat, so please feel free to ask any questions in the chat. Feel free to unmute yourself if you wish. I think you should be able to do so. Yeah, so I don't know if you guys have any questions. Otherwise, we can just start with the course. Oh, there is one detail. One of you asked, and this is usually the way it works at UofT, right? When we used to have the regular courses. We usually start 10 minutes after the hour, and that's kind of a tradition. That's what we call the UofT standard time. And, you know, with the online format, that perhaps doesn't make too much sense, but I think I have one of your peers asking if we could do that, start at every Monday at 1:10 p.m. because this person has another commitment. So maybe my first question for you is, well, I hope that you can hear me. I didn't ask about that, but I hope that you guys can hear me well. My second question will be if you guys will be okay starting at 1:10 p.m. or if you would prefer to start at 1 p.m. Sharp. I mean, it will work for me and even for this person, because as I say, we are going to record everything. So, well, not everything, but the lectures for sure. So if you have any preferences, please do let me know. It can be on by private or on the chat, however you prefer. Okay, so the first thing I'm going to do is I'm going to start by sharing my screen. And let me put this in full screen mode first. And then share my screen. So please let me know if you guys can see my screen. It should show by now the slides for today. Okay, usually I have a multiple monitor setup, and sometimes I get confused with the windows. So but hopefully it will work. So these slides, by the way, are available. I usually try to put them at least one day in advance the lecture in the course website, which we are going to see in a second as well. But this is our first set of slides for the class today. As I told you, my name is Marcelo Ponce. I work at SINE, which is the Supercomputer Center at the University of Toronto. And we can talk a little bit more about that later on. So let's talk a little bit about the formal details of the course. So the course is aimed to be an introductory course to programming, and in particular to using the R language. So the idea is that you don't need to have any previous exposure to programming or coding. If you have it, of course, that will be ideal, but hopefully we will build our own skills in programming and coding, and that's the main idea. We are going to be meeting for 12 weeks. That means 12 lectures that we're going to have once a week on Mondays, starting today, obviously, and usually the time is between 1 and 2 p.m. As I say, we may start at 1:10, following UofT tradition, but also trying to accommodate some of your requests. The class, as I say, is going to be held online. This is the part that is going to be interesting for you. I hope that the whole lecture and class is interesting for you, but this one in particular, we are going to have approximately six assignments. We can accommodate that as we see fit. The idea is that every 2 weeks, when we're going to be covering a meaningful amount of material and topics, we're going to have an assignment. This is a homework assignment, so you will be working by yourself on the assignment. We're still going to have office hours. The due date is 2 weeks after the assignment is presented. So not today, next Monday, I'm going to provide you an assignment, and then you will have 2 weeks to work on the assignment, and that's it. So your final grade is going to be the average of these 6 assignments. So we won't have a midterm, we won't have a final examination. It's just going to be all based on assignments. And the assignments are going to be just coding. It's very, very practical on that regards. Usually, we have a policy for accepting late assignments, but that carries a penalty. So you lose basically 5% of the total grade of the assignment for every day that you are late. But because the classes are so spread, usually this course, I usually like to teach it like twice per week. So everything is compacted to 6 weeks. But after having some discussion with the graduate coordinator of your department, we agreed to have this it's kind of a trial run, having every 1 week. And so everything is dispersed. So it wouldn't make too much sense actually to have the late penalties. Having said that, because again, the special conditions and situations we are living currently, if you run into any trouble with the assignments, please do let me know. The idea of the assignments is that you can just practice whatever we see in class. So it shouldn't be a struggle much more than just practicing and implementing the things and the ideas that we see in class. The assignments are going to be submitted through the class website, which I'm going to show you in a second. So we are not going to use Quercus or anything like that. We're going to use just the class website, which I believe most of you were able to log in. That's why you have the Zoom credentials. We're going to have office hours once per week. So effectively, it will be 1 office hours per lecture. And my initial idea is to have them on Fridays. I think I put in my email, I can't remember exactly the time, but it was something around 1 p.m., I believe. But again, that's something that we can accommodate. I'm teaching another course right now, so I may have some constraints in the time, but also I'm flexible to move things around, okay? In addition to the office hours, we're going to have 2 basics or mean ways of communicating and asking questions, or 3 ways if you wish. One way will be during the office hours and the class. Of course, as I told you, you are more than welcome to ask questions on the chat or unmute yourself. That's fine. The other way is a forum that, as I promised, I will show you in a second in the course website. And the third way is to email me at this email address. So courses@signed.utoronto.ca. So you can email me there. It's just fine. Let me see. Any questions about this? I haven't said much yet other than details about the course. I would like to bring my the course website. So let me just open a new browser. Oops. See if I can move this up. Oh, okay. It's because I need full screen mode. Okay, just 1 second. Okay. As I told you, sometimes with so many windows, I got in trouble sharing the things. Screen. So now you should be able to see, okay, this is not the course that we are talking about, but this is the course website for all signed courses. And the course that we're talking about is Introduction to Programming with R. So this is the main course or the main website for the course. As you can see, I already started to populate some of the things on the right side under content navigation. So we have the description of the course, the Zoom meeting information that you got, that you guys already got, the lectures. This is where you're going to be able to find the slides. And the recordings are going to be in a different category, but also linked here. And then we will have an assignment category. And as I was mentioned before, we're going to have a forum. So I started by creating just a template here for a question, but you can just post your questions here or basically go back to the forum and create a new thread. Okay, one nice thing of the forum, I already have done this, is that you can subscribe to the forum. So every time that someone posts something, you get an email with the email that you are registered for the course. So I get notifications when someone posts something on the forum. Okay, there will be an additional tab here as soon as we open the assignments. It will be called Assignment Dropbox, and this is where you are going to be uploading your assignments, which, as I say, will be mostly not 100% coding assignments. So we're going to be writing programs, writing code, and that's why you're going to be submitted. Any questions so far? I'm going to go back to the slides. I just wanted to show you the course website. I hope that everyone was able to access and log in into the course website. So this is a shortcut for the course website, or you can just go to courses.signed.utoronto.ca and look for the course. As I say, lectures will be streamed via Zoom. They will be recorded and posted on the course website, hopefully a few minutes after we are done. Sometimes it takes a little bit longer, but no more than an hour. The slides will be posted as I show you in the course website. We have the forum. Office hours will be online using also the same Zoom credentials. So you just need to remember one's credentials, and that is it. One important thing, I usually get this question, is office hours will not be recorded, mostly because it varies a lot, right? I can promise that it will be useful content for everyone, because the idea there is that you guys can come with your particular questions and ask anything. Even sometimes I get questions not related to the course, but to the research that you guys do on how to implement something. So it's a very open format. It's very flexible. It's not structured at all. Sometimes we have students just coming for listening other questions, and that's just fine as well. So you know, it wouldn't make too much sense to record those office hours. If there is a particular tutorial in something that is, you know, something that can be useful for everyone, then we may record that part of the office hours. But in general, I would say office hours are not going to be recorded. The questions, as I mentioned, forum or email or office hours or lectures are just fine. Okay. All right, what else? This could be interesting for you, as at the same time that you are going to get credit for this course in your graduate degrees. I think most of you are master's or PhD students. You can also get credit for signed certificates. And so the way it works is at Assigned, we teach a lot of courses, many courses as graduate courses at different units: biochemistry, physics, the Institute of Medical Science, even at the UTSC campus. And in addition to that, we have the smaller courses that are not necessarily graduate courses. So we like to give students credit for taking those courses. And the way we do it is we have a system where we can credit we can give you just some signed credit. These are not university credits, but they are signed credits. And when you get 36 credits in different categories, we have a high performance computing, scientific computing, or data science category. When you get enough credits in each of them, 36 in each of them, then you can request a certificate on each of these categories. More details about this is also in the signed courses website. There is a certificate program on the top. So I invite you to take a look. This course in particular accounts for 18 credits, 9 credits towards the data science certificate and 9 credits towards the scientific computing certificate. And as I say, as far as you finish the course and you approve the course, those credits are automatically available for you. And we basically register all the courses that you take using the accounts that I created for you. So if you later on want to take more courses, there will be the chance, and then you can keep adding credits towards any of these certificate programs. Okay. Right. Let me see what else. So I think I talked a little bit about the class expectations. The prerequisites are minimal to no programming experience. Basically, the goal is to start very slowly and to put everyone. So if you guys have some experience, some of you have experience programming, you may find that the first maybe 2, even 3 lectures are going to be a little bit boring for you and going to be going to a slow pace. But my goal is to put everyone on the same page and then start to build some more interesting features and try to learn good ways of coding. What are you going to be using and needing for this class? This is a quite important thing. So 2 things mainly. We're going to learn how to program in R using the R language. We're going to be talking about R today. So you obviously are going to need R. I think I sent the links, and please, if anyone has problems, either on the chat or any of the other ways that you know now for communicating with me, let me know, okay? So that is vital. The other thing that you are going to need is a text editor. And a text editor, just to clarify, this is not your Microsoft Word editor. That is a document editor. We need something like Atom or Sublime. Those are good ones that works in different operating systems. Some people like to use Rstudio. I usually don't recommend Rstudio because I teach a different course where Rstudio is not so good. But for this course, I have seen that Rstudio could work just fine. So Rstudio will create an interface on top of R, for which you obviously need to have R installed before, but then you can install Rstudio. I can put a link in the course website if you guys want to any of these editors. But these are the 2 things that we are going to need, okay? I think that I mentioned this, the grading scheme is going to be based on your homework assignments, so the average of your 6 homework assignments. And just to be clear, you need to submit the 6 homework assignments, or how many assignments we will have. 6 is the tentative target. Sometimes we change a little bit if we feel that one of the assignments was too easy. Maybe we do one more assignment. If we feel that one of the assignments was too hard, we make one less assignment. So it's in average, I would say 6 assignments. It could be 5, it could be 6, it could be 7. I don't think it would be 7. At most, we will have 6. But in some cases, if we feel that one of the assignments was like really, really hard, we can do 5. Okay, so I will say something between 5 and 6 is the real number. Oh, by the way, I don't think this is the case in biochemistry, but in other departments, sometimes attendance is mandatory. This is not the case for this course. Attendance is not mandatory, although I will say is highly encouraged, and it could be quite useful, especially for dealing with the assignments and the stuff. But as you know, the lectures will be recorded, so you can watch it whenever you guys want. I talk about the course website. I show you the course website. By now, I think you all have login. If you haven't, well, you probably wouldn't be here because you need to log into the course website for getting access to the credentials. And I think I have mentioned all of this. So let me see. Okay, so last slide about the course details. This is a kind of, I always feel bad mentioning this because I know all of you are graduate students and are mature enough, but you know, in any course I had to disclose this. Please don't copy each other assignments. It's going to be the same problem that all of you had to solve. I'm going to be grading your assignments, and I have so many years of experience coding that I can very quickly realize if a piece of code is copied. So please just don't do it. It's okay to chat between you guys, like discuss solutions, okay, those kind of things. I usually like to say that there is not Googling needed, that you don't need to go into the websites and or Google and try to Google for information. I would prefer that you probably ask me or ask in the forum. The forum is great for that because maybe someone else is sharing the same concern or the same question. So if one posts in the forum, everyone sees that, by the way. Okay, so the forum, you have to be logged in for posting your questions, but anyone can see. So you can even see the questions and the answers to the question without being logged in. So it's publicly open. And if you find, this is like scientific work, right? If you find a solution that someone else implemented, well, just give credit to that. It's kind of fair. But yeah, I would say let's keep it light and easy, and it should be okay. All right, I think these are my let's call administrative slides about the course. Any questions so far? Anything that has not been clear, that you may have a question, concern? Feel free to, as I say, to open your mics or put something in the chat, or privately to me in the chat. I wouldn't mention who is asking, just mention the question if there is any question. Good question, Rafaela. So any of the suggested text editors should be okay. I usually don't use any of those, but I can help troubleshooting problems. The main idea of the text editor is like if you write things in Word, for instance, the Word document processing programs, they put a lot of hidden symbols and characters, and we need just plain text. So either Atom or Sublime should be okay. Let me see if I can show you. I have an installation of RStudio. RStudio is very nice. Usually, as I say, don't recommend it because for some things it doesn't work as nice as just a plain thing. But let me see. So Rstudio is moving, as I told you, Rstudio is moving my stuff, and it puts these floating bars everywhere, but I just want to show you. Okay, for some reason I cannot. Maybe I don't have it in this computer, but I can, as I say, I can put a link. I was pretty sure I have it. Oh, here we go. There we go. So just bear with me a second. I'm launching RStudio and I show you why RStudio is nice. We probably need to exit. Let me stop the share, and I will show you how RStudio looks like. Okay. And sometimes, depending on your computer, RStudio can be a little bit slow. That's what is happening with mine. I had several things open, including the Zoom broadcasting. So let me see. All right, so this is more or less how RStudio looks like. You have different panels here that tells you a bit the environment that you are using, some things that we are going to learn later. But then you have here what is called the console. That's the main console. That is very similar to launching R, if you have done that. But then you can just click on this thing here. You can say, okay, I want to create an R script, and that will divide your basically RStudio window into a new window. And here you can just say, this is an R script. Okay, and then we're going to see how to populate this with the real R commands. But basically, you can see your script, that's the text editor, and that's your R console at the same time. I don't think I have installed any of the other text editors, but they basically look pretty much like that. Now, there is another thing, especially, and this is depending on the operating system that you are using. if you launch R, launch R just for the kicks here. So this is the R GUI. You will see that in a second. Okay. I'm going to show one of my desks with you. It's going to be a little bit messy because I have several things there, but you can see at least and compare. So now you should be able to see my whole desk. So this one here is RStudio, as I told you before. This one here is just the R console. This is a Mac OS, so this is how it looks in the Mac, but in Windows or Linux, it will look very similar. There is a text editor here, where it says Open Document in Editor. And this is another text editor that you can use, okay? So I don't think I have anything there. Maybe a new one will do it. Sorry, now printing this one. And this is, again, this is another text editor. So you're welcome to use that one, actually. But as I say, this may depend a little bit on the particular operating system that you're using. I believe most of you may be on Windows or on Mac. If you are in Linux, I believe you probably are very, very, very familiar with any of these text editor or different text editors. Okay, but just to go back to Rafaela's question, I personally I don't have any preference. I think both Atom or Sublime or the RStudio interface or the R editor should work just fine. Okay. Sorry for the long answer, but it's a good question because it's something that we are going to be using for quite some time. Any other questions on this or anything else that they have talked about? All right. I think we mentioned all of this. We talk about this. We talk about this. Okay. So what are we going to talk in whatever is left of today? Probably I don't know if we will have enough time, but this is the idea so far. We're going to talk a little bit about R, a very quick introduction. Then we're going to be talking about variables. And this is something I'm going to spend some time trying to grab our minds about what a variable means. And then different type of variables. Then we're going to be talking about modular programming. Of course, this is not the whole thing for today, by the way. This is the whole idea for the class, by the way. So today is going to be just about starting R and what R means. Then we're going to be talking about the different data types, modular programming and modularity. This is going to be a big topic for us. And as I say, this is where things are going to get starting to get interesting, even if you have programmed before, because this is a very robust approach to coding that not everyone may be familiar with. We're going to be talking about some statistics, how to say data that we produce, how to visualize data. Usually people is very interested, and I'm very fond of visualization techniques. And then we have other topics. So even when I have a syllabus, which I think is in the website, we have freedom to vary some things. So that's something that I would like to have your input. If you have any particular preference or would like to discuss any particular topic that you think it may be useful for your own research, please do let me know. The sooner the better. So if there is something I have no material, I can prepare material on it. But we have topics that it can be machine learning, high performance computing using R, and a variety of others. So there are a couple of things that we can modify the course just to fit your personal preferences. For today, as I say, it's just going to be part of this first bullet point and a few others from the second one. But it's going to be more about what is R, how to start R, the primitive data types that we have in R, and container types, okay? So the idea for today is just to, if you haven't used R before, just to get used to what R is and how we will work with the very basic elements in R. Okay, just to have an idea, how many of you have used R before? You can just raise a hand or put something in the chat. It looks like not many of you. How many of you have a coding experience? Okay, oh, sorry, I was looking at the wrong. Okay, I see one hand. Okay, one hand, two hands. All right, okay. All right, okay, it's going to be fun then. So let me start with the very basics. And as I say, I apologize if this is too basic for you guys. You are always welcome to let me know if we should, if we're going too slowly or with too many basic details. That's fine. We can adjust things as we go. Okay. So what is a computer program? So a computer program is nothing else than a precise set of instructions that we tell the computer with the goal of obtaining something. Think about writing a letter, right? What will be the precise set of instructions that you need to do or give to the computer to do so? Well, let's say you open your computer, the computer is on, you go and double click on the icon of the application that you want to use to write the letter. That will open a document or open the program, and then you need to create a new document and then start to type the text, right? That will be the process. So the instructions will be double click on the program that I want to use, create a new file, and write the text. Kind of like that, but with more concrete goals, right? So the example of writing the letter may be too peculiar or too particular. Generally speaking, for scientific computing, on scientific computing, I'm being very vague, can be any kind of data analysis, statistical processing, whatever you can think that it can be done in a computer with scientific goals. You are going to be defining variables which contain your data and perform operations on those variables to do calculations which you need. A more closer example than just writing the letter could be something like writing in a spreadsheet, like with Excel, for instance, where the columns will represent measurements of a given quantity or a given experiment. And then let's say you want to compute the mean value of that, and you want to compute the standard deviation value of that quantity, or do some other kind of analysis, try to find if there is a regression that fits that data or something like that. You also define your own personal functions. That is something that we're going to spend some time, and it's going to be part of your first assignment, how to define functions that then can be reused over and over with different parameters, different data, different values, and don't need to rewrite that thing every time, like open the Excel sheet and then do all the operations again and again and again. Have a function that can do that for you. Vicendra, do you have a question? I see your hand raised, but I don't remember if it's because you were saying that you have experience. If you have, let me know, okay? Just you're free to ask questions in the chat, anyone. What else? There's a lot of programming languages out there. Each of them has different features, strengths, and weakness. The reason why we are going to be using R, or R is the one that we're going to be using, is because a lot of things just work in R, especially all what is related to statistics work kind of out of the box in R. And there are a lot of goodies and extra additional functions that we can load, and we're going to see how to do that using R. So a little bit of R history. R has been around for a while. It's not as old as other programming languages, but it was introduced in 1996. At that time, it was called the S language for a statistical language, or it was a mathematical-driven language. R is mostly designed for exploring and analyzing data. And you know what? One of the strong suits of R is that it's very good to be used interactively, like meaning no writing programs, but just exploring the data. Now, this has advantages and disadvantages, as you can imagine. One of the disadvantages is you have a good amount of data, and you need to be performing over and over and over this analysis. It can be very labor intense if you want to do it every time interactively. So better approach is, okay, you do it once interactively, but then you create a script or a program that you can rerun over and over, and then you minimize the amount of work, you minimize the chance of making errors by typing things interactively. And so it has these advantages. The homepage for R, the main reference is this link, which I believe it was also in your introductory email. There is a lot of packages contributed by the community. These are stored in what is called CRAN, which stands for Comprehensive R Archive Network. Many bioinformatic packages are also installing what is called Bioconductor. So you may have heard of these two. These are the two main repositories. CRAN is a peer-reviewed It's kind of when you publish something in a journal, it's a peer review repository. So usually packages on CRAN are well tested and they are trusted somehow. A new version of R is released each year. I think this is updated. The current one is 404 or something like that. So you don't worry about the 363. This is a leftover from last year. I think we're at 404 or something like that. A little bit more about R. R is what is called a scripting language. If you have heard about Linux shell or Python, these are also scripting language. What it means is that there is a program, which we call the interpreter, which basically executes each command line at a time. So every time that you write a line in R and then you hit enter, there is a program that will take that line and it will try to interpret what is that line saying and execute it. R can be used, as I mentioned, interactively with or without an IDE. An IDE stands for Integrated Development Environment. An example of this is Rstudio, as I was showing you before. R can also be run in a non-interactive manner through scripts, and we're going to see how to do that. R has a large repository of community packages. This is the CRAN and Bioconductor repositories, as I told you before. So if there is a functionality that is not part of R, it's quite likely that it will be in an additional package, and we're going to see how to install these packages from CRAN or Bioconductor. Most of the things that are done in R are about data analysis. So it's not a general purpose language. What I mean with this is if you are running, for instance, a molecular dynamic simulation where you try to represent the positions and composition of a substance and the evolution in time or the mix of fluids or chemicals, you could do it in R. There are packages that probably can help you do that, but it's not where you're going to do it because several things. It's not the natural way of R to tackle those problems. The other thing is performance-wise, there are other languages, Python, for instance, that can do the same thing in better times or using less resources, less computational resources. We may talk about this if we decide to do the high-performance computing class in R. But the main thing, I would say, the main type of projects that you may want to tackle with R is data analysis. Having said that, it doesn't mean that we cannot try to solve other problems. Like we can try to solve differential equations. We can try to create models that represents the evolution of a population or things like that. Many important features are already part of the language, numerics and visualization, for instance. But as I say, many people or most people won't use it for what is called number crunching, like performing like really heavy computations. R is designed or was designed with interactive data exploration in mind. So many things just work. But in some cases, depending again on the problem that you want to try, running interactively is not the best idea. And we are going to see examples of this and what is the alternative to not running interactively. So this is a moment if you want to follow along, you can do it, or if you want to do it later, you can do it as well. I'm going to just follow the slides. I usually, if we have enough time, I'm going to open an R session. I may do it if you guys have questions and go in parallel with the lectures. Let me know if you prefer that we do that. It may take a little bit more of time, but you know, you can start R now, which basically means if you are in Mac or in Windows, you double click on the R icon, or if you're in Mac, you launch the terminal and you type R, and this should basically open your R session. If you want to follow along and you're having trouble with this, please let me know, raise your hands or put a comment in the chat. Okay, but let me know. So let's see. So this is, maybe it's a good idea that I open, I think my R session is somewhere over there. So let me see if I can, there's a way to do this. Okay. So that's one here, and then I want my R session right here. So I'm going to make things a little bit bigger. So I hope that by now you guys can see, maybe this is better. You can see my slides and the R terminal. And what I'm going to do is I'm going to be showing you how to define variables in R, and at the same time talking about the different type of variables. So for starting, what is a variable? Is everyone familiar with the concept of a variable in computer or in programming languages? I'm asking because sometimes if you're not familiar with this, is it's a little bit confusing with the concept of variable coming from math. So usually in math, a variable is something that can change. Well, it's kind of the same idea in computers, but usually we refer to them as places where we can store information. So maybe a closer idea to a variable in a computer program is like a drawer, where I can open the drawer and put some information, some things inside the drawer. Now, the peculiarity with many programming languages is that this drawer may accept some particular type of information. For instance, the first type I want to talk about is the numerics. So if I want to represent numbers, I can start by defining a variable. So how does this work in R? Well, I'm going to pick a variable. So my variable is going to be called A. And then I'm going to use this weird symbol, which is nothing else than the smaller than symbol followed by a dash. And that is what we call the assignation operator. So this means put in the variable A whatever I write on the right side. So in this case, 1. And I hit enter. When I do that, it looks like nothing has happened in R. Okay, I can do the same with B. I can do put in the variable which I'm going to be called B from now on, the value 1.73. I'm just following the examples on the slide. And I just hit enter there. And by the way, this greater than red symbol is what we call the prompt. It means that R is waiting for us to type instructions for him. Each of these things I wrote here are instructions. So the first one is telling R, okay, I will create a variable called A, and the variable will contain the value 1. In the second, I will create a variable called B, and the variable will contain the value 1.73. Okay, now if I type A, R, I just type 8 and hit enter, R will say, oh, A has the value of 1. Okay, don't worry too much about this bracket 1 that shows up here. It's a way to tell for R to tell us that the variable contains just one element, and this is element number 1. We're going to see more variables or variables containing more than one element. But this is a way to tell us, okay, there's one element and the value is 1. If I do the same with B and hit enter, then the value is 173, which is what we will expect, because we open a drawer called B, we put a label on the drawer, and on B we put 173. Okay. What is the nice thing of this? Well, now I can operate with these two variables. I can do A plus B, and that will just basically add 1 plus 1.73. Or I can subtract them. I can do A minus B, and then I will get the subtraction between 1 and 1.73. The other nice thing is I can assign the result of this to a new variable. So I can say, okay, put in a variable D, the result of doing, and again, the smaller dash symbol represents here the assignation operator, A minus B. It doesn't matter if I leave spaces or not spaces. It's just the mathematical symbols are the ones that differentiate between variables, right? So now if I ask for D, it's the same as having done A minus B. Okay. Any questions about this? And again, please let me know if most of you are familiar with this. I'm happy to crank up a little bit the speed. I usually try to go slow here in case that you haven't seen these kind of things before. Okay, is the concept of variable more or less clear? Any questions about that? Okay. So I have shown you basically these are numbers, and the good thing of having this type of variables is that, as I show you, we can operate with them, right? We can perform mathematical operations of them. For instance, if I do the other interesting thing, and this is to clarify what the left arrow operator, the assignation operator does, is do this operation. assign to A the result of doing A plus 1. So what do you think is going to be the value of A after doing this? It's in the slides, actually, right? And it's going to be 2. And why is that? Well, the reason is what R is going to do, it always evaluates the right-hand side of the assignation operator first. So A, until this moment, I'm going to ask for A, is 1. So if I do A plus 1, I get 2. And what happened here is put in A, that's how you will read it, put in A the value of doing A plus 1. Okay, and now A is going to be 2. Okay, I mentioned this is a very simple thing. I hope it's clear, but this is going to be super useful and super used in our programs. So it's better that we clearly understand this, okay? It's again something simple, very simple so far, just playing with the variables, the values, and assigning. If something is not clear, let me know. It's important that you guys understand this basic concept right now, okay? Another example of this is the following operation. I can reassign to A, again, the value of A divided by 2, and then add 3. So A divided by 2, because A is 2 now, will give me 1. And if I add 3, then it gives me 4. So if I ask for A now, A has the value 4. Okay, it's all good? It's clear? Okay, I hope it is. If not, please do let me know. Now, I told you just a second ago, these are just numbers. These are numerical values. But R can have different type of variables. For instance, we are going to see how to do strings in a second. But also R has some functions defined that it can tell us a little bit about what variables or what type of variables these are. For instance, an example of this is the type of function. So I can say, and by the way, you can type part of the function name and then press tab, and I will try to complete this function. So type of is the function I want. So if I ask for the type of, and then I say between parentheses is the argument, is what I'm asking for the type of. So the type of A is what is called a double. And double is nothing else than a fancy name that R gives to the numeric types. So when we are having variables or numbers storing variables, that's one way of saying, okay, this is a number, okay? Now, remember our variable B that has a number as well? Well, I can do something. R allows you, and R and Python, other scripting languages, allow you to do this, to override the value of B, being a number, with the value of the result of a function. So the function type of will returns the word double, which is also between quotation marks, means that this variable now is not a number anymore, is a string, it's a set of characters. So if I assign to B type of A, and now I ask for B, type of A assigned to B the value of A, of type of A, then B will contain the word double. So this is a string. So Sina has a good question. Are there integer types in R? Or so it's a good question. There are integers. So A is an integer if you want to force to be an integer. So it's a good question, Sina. You can use the function as integer. So I can force 1.0, which in principle will be a float, a number with a decimal point, to be an integer. And then you are forcing whatever is that value to be an integer. So yes, it has. How I represent those numbers underneath, it doesn't really matter much, but if you really need to have an integer, because we will see why you may want to have an integer, you can do it by forcing it with the as integer function. Okay. It may happen in general, though, as you saw here with the example of A, that the most general type of representation, numerical representation in R, is a double. Okay, but you can't force the numbers to be integers. A good example of why you will do that is to save memory. Like integers, the representation of an integer value, a numerical value, which is just the integer part of the number, saves a lot of memory sometimes in meaning how big is the variable that is stored in the program. So in some cases, you may want to do that, okay? Especially if we are talking about 1 million elements in an array or something like that, that will say a substantial amount of memory. So it's a good point, okay? So when we say I'm using the function type of A, that function is returning the word double. That is what the function returns. It's what the function gives back when you call it. It's like when you call, by the way, you can do a square root of 4. Oops, square root, come on, of 4. That function will give me 2 because the square root of 4 is 2. That's the returning value of the function. It's the result that you expect from the function. In this case, it's a string saying what type of variable that is. Similarly, as integer, which basically takes a value and basically try to cast it into an integer, there is a testing function called isNumeric to know if a variable returns or contains a numerical value. So if I ask isNumeric of A, it says true, which is true because A has 4. But if I ask for isNumeric of B, it says false because B doesn't contain a number anymore. It contains the word double. Okay, is that clear? Okay. So again, let me know if there are any questions about this. I'm going to make a parenthesis here and probably won't have enough time to cover all the slides. I probably was talking too much, but let me just go with this. So the types of programming, all what we have been doing so far here on the right side of the screen is what we call interactive programming. Basically, what I'm doing is just typing instructions, hitting enter, and when I hit enter, I execute these instructions. But alternatively, I could have put all these instructions in a text file, as we were discussing before, and save that text file and execute that text file, which basically will pretend as if I were typing the instructions in front of the R terminal and hitting enter 1 line per time. So this is what is called a script. And the set of commands of lines that are put in the script are basically the program that R is going to run, okay? There is a third type of programming, which is basically when you take your script and you compile, and what it means compile is you put in the language that the machine can directly understand, which makes it super fast, but it has a lot of restrictions. We're not going to see that type of thing. So R is a scripting language in that regard, so we are going to take our instructions, put in a text file, and ask R to execute at some point. Okay, so that's just a parenthesis to describe a little bit about the programming types. Let's play a little bit with a different type of variables. We were using numbers right now, numerical variables. So let's use the variable E now and put the word hello. I'm going to use double quotation marks and hit enter. And then the variable she, which again, I'm using the same assignment operator, but I'm going to use single quotation marks, and I'm going to use word. And then I'm going to declare a new variable, my string, and I'm going to use a function from R called paste. And paste, basically what it can do for you is kind of the addition operator for strings. It can combine, it can paste together two string type variables. So I can do E, she, E was hello, and she was word. And then I can ask for what is my string. And now it says hello world, okay, with a space in the middle because the paste function adds a space between the two strings that you want to paste, to combine together. If I do E plus she, it won't work because these are no numbers anymore. And that what we are seeing is an error, right? It says, error in E plus she, these are non-numeric arguments to binary operator. Let me translate this for you. The binary operator is nothing else than the plus sign. So the binary operator is a function that takes two, that's why binary, entries, E and she, and it was expecting two numbers. But these are non-numeric, so these are strings, that's why the non-numeric argument to the binary operator plus. So for adding strings, for combining strings, we need to use the paste function. Another way, a better way to display the content of variables is to use the print function. And you notice every time I say function, there are parentheses involved, and whatever goes inside the parentheses are the arguments, are the information that the function needs to perform something, like the square root of 4. it needs the number 4 to compute the square root of that number. So in this case, print my string, oops, inside the parentheses, will do the same as calling my string. Usually this doesn't work in scripts. So if we put this line alone in a script and we try to execute, the output will be none, because R says, okay, a string doesn't, a variable doesn't mean anything. But I say in print, now R knows that we actually want to print that content. Okay. All right. A little bit of clarification, or not so clarification, but discussion about a string versus variable names. Let's reassign a, or very first variable a to 1. So a is 1. Let's assign b to the letter a. Notice the double quotation mark or single quotation mark, doesn't matter, but b is now a. And let's assign d, another variable d, to the variable a. So what is the value of d here? And I know it's a little bit of confusing on purpose, the selection of names, and that will raise a point later on. Having variable names with only one character is a terrible idea. I'm just doing it here for the sake of speeding a little bit examples and don't overcomplicating the main concept here, which are the variable types. But it's a very, very bad idea to have variable names of just one character length. It's better to be more descriptive with the variable names like my string or something like that. Well, d, because I was assigned the variable of a, basically the content of a, will have 1. Okay? And that is basically because a has a 1 on it. And don't be confused, b is still the character a. Okay? Okay, one more type. Let's see how we go in time. Let's see at least one more type. This is what is called Boolean variables. And we saw a little bit of this when I was asking the question, is the variable a numeric? Remember the is numeric function. And it was saying true. And if I ask is numeric, the variable b, and it was saying false. Notice these true and falses. These are ways in which we can communicate with the computer, with the programs. It's basically the very foundational level at which we can communicate and ask questions to the program and the computer, asking true and falses. So these are called Booleans or logical variables. It means that I can say something is true or not true by being false. So notice that they are all capital letters, and this is important in R. R is what we call case sensitive. So, by the way, A is not the same that capital A. If I ask for the value of A, I define it as 1. If I ask for the value of capital A, R doesn't know what capital A is because I have not defined it yet. The same is true with true, and capital true doesn't know what capital T RUE is. It knows what all capital true is, or it knows what capital T is alone, is a shortcut for true, or false and F, but not false just with, you know, the first 2 letters, or just F alone in capital letters. Okay. So 2 important things here. R is case sensitive, so capitalization matters. It means something in R. And then Boolean variables are always referred with all capitals. Okay, so it's what we call shouty, if you wish. So let's take the example of F and say F is false. Oops, false. Now if I ask for F is false, the exclamation sign in logical variables or Boolean variables works as the complement. So F, exclamation sign of F, is the opposite of being false, which is true. So it's a little bit of Boolean or logical logics, if you wish. So the opposite of false is true. If I ask for the type, remember type of the variable F, now it's going to say it's a logical variable or a Boolean variable. Okay, and in the same way that we had is numeric, we have the is logical function, and we can ask is the variable F logical, and it will say true. Now, one funny thing in R, Booleans, Sina was asking about integers, right? Booleans can be seen as integers. So for instance, I can add 2 truths, and true plus true in R is 2. True plus true is 3. True plus false is 2. And false plus false is 0. In other words, truths are represented as ones, and falses are represented as 0 in R. Okay? This will come back later, and you will see why this can be useful. Okay? Let me just do a couple more of slides. I think we started a little bit late, and I spent some time in the introduction, so I will take a few more minutes and then stop. Feel free to ask questions again if you have any questions. Just a recap, the basic data types that we have seen is numeric, include floating point numbers, which means decimal point numbers, usually known as double precision numbers, include logicals or Booleans, meaning true and falses, only 2 types, 2 flavors of Boolean, nothing else, and then characters or strings. Okay. In R, the idiomatic assignment operator is this left arrow, the smaller than symbol followed by a dash. Logical literals are shouty, as I say, all true or false, all in caps, or T and F alone. Variables can include periods in their names. So for instance, I can say variable A being 123, and then var A will be 123. This is an important thing, and it will show up later, and in many of our scripts it's going to be a substantial amount of this. The hashtag or number symbol are comments, which means, for instance, I'm putting the hashtag, and this is a comment. Oh, come on. So, a comment is going to be ignored by R. This is super important. It may sound like silly. Why is so important if this is not interpreted by R? So for instance, if I type this sentence again, but without the hashtag, R is going to complain. I don't know what you're talking about. This is not a comment I know. It's nothing I know. But if I put the hashtag in front of it, basically it doesn't complain. This is super important because this provides a way for us to describe what our programs are going to be doing. What are we trying to achieve with our programs? So it's going to be substantially important, very important in the assignments, very important in programming in general. I think I mentioned this last part. R is case sensitive. Capital A is not the same as A. So be careful. This is a source of mistakes sometimes. Let me see how are we doing with time. So how are you guys doing? Do you have any questions so far? Is this more or less clear? Oh, good. That's great. Thanks, Zapas. Again, feel free to let me know. I'm going to spend, say, 1 more minute just talking about dynamic typing. And then we are going to leave the composite types for next week, okay? So, and I really would appreciate, for instance, if you let me know if you feel that we're going too slow. I know we spent a good amount of time, almost half of the class, talking about the details of the course. But if you feel that this pace is okay for you, you would like to go a little bit faster, if you would like to go a little bit slower. If you don't say anything, I will assume that the pace is okay. But if you want to go faster or slower, just let me know, okay? It's the first class though, but you know. So what I mean with dynamic typing means that a variable can change its type. Basically, that drawer I was talking about, it can accept different things, but when it accepts one thing, it's that thing only that accepts. So for instance, let's take the case of the variable A. A has 1 on it right now, but I can say, okay, you know what? I want to put some pants. This is an example that one of my colleagues likes to use, pants. But it's a word, basically, what I'm saying, right? So if I do pants, A, assign pants to A, now A contains pants. And if I say type of A, basically, it's a character. But I could say, okay, put a true in A. And then if I ask for A, it's true. And if I ask for the type of A again, now it's a Boolean. So R has no problem whatsoever in changing the type of the information stored in the variable A. And that is what is called dynamic typing. okay? It can change on the fly what type of information can be stored on a variable. This is an important and crucial difference with other languages, because this is very flexible. This is something you would like to have because you don't want to be restricted. I don't know if it is a good idea though, but you don't want to be restricted to only one type of information being stored in a variable, especially when you're doing interactive inspection of the data. But other languages do not allow you to do that. And the reason is performance issues. So as we saw before, numerical variables can be added together. So I can do 1 plus 2, no problem. But I cannot do, for instance, if A was pants, as before, let me go back. By the way, I'm using the up and down arrow here to circulate between my commands. I cannot do A plus A because A is not a number anymore. So that dynamic typing change in the variables means that R has to check every time that an operation is going to be applied to that variable, that is a valid operation to apply. And that in terms of performance is hitting your performance, right? Because if I know A is a numeric variable, then I can do A plus A, no problem. I know at the very beginning A is a number, it will remain a number, it will never change. But if at the beginning of my program A is a number, but then I put a numerical a string on A, then I had to check every time I want to perform an operation on A. And that is expensive because it means that I need to go and check the type of the variable. Not me personally, but R, okay? So, okay, so as I promised, I think we're going to stop here. We have a few more things to discuss. We're going to leave this for next class. Probably we'll need to start going a little bit faster, but I think that for the first class, this is okay, all right? Any questions so far? Great question, Shada. Examples of compiled languages are Fortran, C, C++. Those are the most common ones. And those are languages that are mostly used for what we usually refer as numerical crunching, like a lot of computations. It can be simulations of different things. It can be solving numerically differential equations, studying parameters space with different numerical values. So those are the most common ones, and the most performance-wise programs or languages. If you are going to use a CPU, which is something we didn't talk about, we may talk about if we do the HPC4R class, if you're going to use graphic processing units instead of CPUs, which is the basic element for computing a computer, you may use CUDA or OpenACC or OpenCL. But in general, Fortran, C, and C++ are the paradigmatic cases of compiled languages. Okay. All right. No problem. So if you guys don't have any more questions, we're probably going to stop right now. As I say, the lecture, the recording of the lecture is going to be available later today, probably in an hour or so. I need to just post-process after Zoom is done. I post-process the recording and I will upload it to the website. Okay. Feel free to contact me at courses@scinet.utoronto.ca or the forum, and let me know if you have any concerns, any questions, and as I say, how you feel about the pace of the class so far. I know we haven't seen much, but usually this class go a little bit slow, but we'll try to go a little bit fast. All right. Okay, guys, have a good one. Was really nice to see you all here, and I will see you on Friday. Oh, by the way, let me know also if Friday 1 p.m. works for you for the office hours. Okay, and I think I haven't heard anyone or any concerns about starting at 1:10 on Monday. So I think we're going to start 1:10 from now on. All right, we can start at 1. Especially if you guys want to discuss or review any of the material that we covered the class before, or probably when the assignments are going to be posted, discuss some of the assignments as well. All right, but the lecture time will start at 1:10 and we will go up to 2:10. Hopefully, maybe usually I'm well known for expanding a little bit as the course goes by, but I will try to promise to control myself on that. All right. Okay, guys, have a good one. I will see you soon. You too.